Hello, hi everyone. Welcome to the Student the Brand. Hello, students. Welcome to the Student the Brand. This is Evasavasa. Today's topic is current electricity, grade 12. Right? Okay, so I'll discuss clearly about it. Current electricity. Okay, so first point is the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. So generally we can say I equal to Q by T is the rate of net charge flowing through unit cross-sectional area per second. Okay. I equal to Q by T. But I equal to dQ by dt is instantaneous current at that particular time. Instantaneous current at the particular time. Okay. So I equal to Q by T, that is average current. I equal to dQ by dt, this instantaneous current. Understood or not? So I hope it is very clear. The rate of flow of net charge through a unit cross-sectional area per second is called electric current. Okay. And I equal to dq by dt. I equal to dq by dt is the flow of charge at a particular instant, the flow of current at that particular instant. Understood or not? So that is called, what is that? That is called instantaneous current. So we know that SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. 1 ampere is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross-sectional area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross-sectional area per second. So one SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. Understood or not? So I hope it is very clear. Now here we can take inside of the conductor. So will you say only one electron flows in the conductor? Will you able to say current is flowing? Only two electrons flows, will you able to say current is flowing? Only three electrons flows, will you say current is flowing? No, we can't say like that, right? Number of charges are moving in the conductor. Number of charges are moving in the conductor. Then only we can say current is flowing in the conductor, right? So that's why charge is quantized. Q equal to plus or minus Ne. So number of charges, that too, positive charges are there, negative charges are there. So that's why Q equal to plus or minus Ne. So N is the number of charges. So on one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. Okay. So on one electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19. Then you'll get 1 coulomb. Okay. So 1 by 1.6 into 10 power 19. Okay. Okay. So here you can see so that is 19. Then you can see 1 coulomb equal to 0.625 into 10 power 19. Then if you get, so 1 coulomb 6.25 into 10 power 18 electrons. Understood or not? So I hope it is very clear. Just check once. So I equal to Q by T is the rate of net charge, the flow of net charge the flow of net charge through a unit cross-sectional area per second. Okay, so that is I equal to Q by T and I equal to dQ by dt. So instantaneous current. So current at the particular instant. Okay, SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So number of charges are moving in the conductor. Then only we can say current is flowing. Okay, so only one electron flows, only three electrons flows, only four electrons flows. We can't say current is flowing. Number of charges, that two positive are there, positives are there, negatives are there. So number of charges are moving in the conductor. Then only we can say current is flowing. So Q equal to plus or minus Ne. N is the number of charges. So on one electron, 1.6 into 10 power minus 19 coulomb in one coulomb, so 6.25 into 10 power 18 electrons are present. Understood or not? So if charge is, so now you can see the flow of charge can be obtained by multiplying I into delta T. And coming to the second one, if the flow of charge will be function of time, TF, so I into delta T. Okay, I into dt you can take. I into dt. I into dt. So dt. And coming to third one. Okay, so the flow of the net charge can be the flow of charge can be obtained by IT graph. Okay, current and time graph from the time. So area under current and time graph. Understood or not? So this can be done. And coming to the next one, so there are two types of current based on the magnitude and direction. Based on the magnitude and direction. Okay. So one is direct current, second one is alternative current. One is direct current, another one is alternative current. Understood or not? So direct current, coming to the direct current, so magnitude and direction does not change with respect to time. Okay, so magnitude and direction does not change with respect to time. That is called direct current. Example cell. So we can take example cell, battery, and DC dynamo. DC dynamo. And coming to the alternative current, both magnitude and direction changes. Both magnitude and direction of current changes. So AC dynamo. Understood or not? So I hope it is very clear. So if the charge is moving in a circular path, so Q is a charge moving in a circular path with frequency f. So I equal to QF. I equal to QF. Understood or not? Once again. So DC current is nothing but both magnitude and direction of current does not change with respect to time. That is called DC. And coming to the AC, so both magnitude and direction of current changes with respect to time. That is alternative current, AC. And here example for AC dynamo, example for DC, cell, battery, and DC dynamo. Understood or not? So if the charges move in a circular path with frequency F, then I equal to QF, right? Yes. Coming to the next one, drift velocity and relaxation time. Drift velocity and relaxation time. So we'll discuss about drift velocity and relaxation time. Okay. Drift velocity and relaxation time. Drift velocity drift velocity and relaxation time. Relaxation time. So what is drift velocity? Okay. So drift velocity and relaxation time. So when electrons are moving in the conductor, when electrons are so current is moving in this direction, electrical field also will be there. So electrons are moving opposite to the electrical field. Okay. So when electrons are moving opposite to the electrical field, it experiences the force, right? Experience the force. F equal to QE or E. Understood or not? We know it produce acceleration. So when force is acting on the electrons, it produces acceleration. Right? Yes or no? So that is F equal to ma. F equal to ma. So ma equal to QE or EE. So A equal to QE or E by M. Okay, so we can also write like this. M. Understood or not? So I hope it is very clear. So, sir, what is the drift velocity? So, what is exactly drift velocity and what is exactly relaxation time? Drift velocity is nothing but. So here I will explain clearly. Listen. So this is the electron. So here also electron is there. Suppose electron is moving in the conductor. Okay. So this electron is moving with some velocity. This electron is moving some velocity. This electron is moving, moving, moving. So what happens? Those electrons are moving in a closed conductor, right? Okay, positive charges are there. So positive charges are there in the conductor. So what happens? Those electrons will hit. Okay, so walls of the conductor and positive charges also. Then what happens? Or so electron also will collide each other. Then what happens? After collisions, the velocity of an electron changes. So initially I'm moving like this. I'm moving like this. Some person is there besides of me. So we are moving in a closed path. So in one direction. So we are moving, right? Then what happens? There are not only one, there are many. There are many are there, right? So what happens? If you are moving in a closed enclosure in one direction, so then what happens? So one person will hit another person, that person will hit another person. Like that, collisions will take place. Here also same thing. So electron will hit another electron, that electron will hit another electron. Like that, keep on bombardment takes place. So you have to understand one thing. Before, electron is moving to some velocity, right? After collision, will it be the same or it will be different? Absolutely, it will be different. Okay. So without any doubt, so after collision, velocity of an electron changes. Sure, either increases or decreases, it doesn't matter. So changes, right? So before, after collision, so velocity changes, right? So like that, all electrons are keep on collisions takes place inside of the conductor. Then the average velocity of an electron moving in a conductor is called drift velocity. Average velocity of an electron moving in a conductor is called drift velocity because they are moving in one direction. They are moving in one direction, so collisions will take place. So before collision will be different, after collision velocity will be different. Before collision velocity will be different, after collision velocity will be different. So average, so overall you can take average velocity of an electron moving in a conductor is called drift velocity. Is it clear? And coming to the relaxation time, sir. Okay, sir. So you said before collision velocity have some electron have some velocity, after collision so velocity changing, so velocity will be changing. So okay, average you are taking, average velocity of an electron is called drift velocity. Okay, what about relaxation time? What is relaxation time? Relaxation time is nothing but, so as I mentioned, electrons are moving in a closed conductor, so collisions will take place. So that is very clear. extraordinary, marvelously, outstanding, amazingly. So we understood that one. But one point you have to clear with that. That is, so this electron is going to hit another electron, right? So with the lattice, so with the positive charges also there. Okay, this electron is going to hit another electron. This electron is going to another electron. This electron is going to hit another electron. So that is very clear. So immediately will it takes place immediately? Collisions will takes place immediately. So one collision is take place. I have to go to and hit another electron. I have to go to hit another electron. I have to go to hit another electron. Like that, it won't takes place, right? So it won't takes place regularly. Yes. So take time. So after 5 minutes, I have to go to hit another electron. After 5 minutes, I have to go to hit another electron. After 5 minutes, I have to go to hit another electron. Like that, it won't takes place, right? So randomly, collisions, dishka. Collisions, go and hit another one. Collisions, go and hit another one. Collision, go and hit another one. Like that it happens. That's enough. Randomly it takes place. Collisions will takes place randomly, not regularly. So electron will put the time. So okay. So now 5 minutes. Within these 5 minutes, I have to do 20 collisions. So like 1 seconds, go and hit another electron. After that, regular intervals, I have to go hit another electron. Will it takes place like that? No, it won't takes place like that, right? So randomly it takes place. Randomly collisions will takes place. So after hitting, immediately it will go and hit another electron. After hitting, immediately it will go and hit another electron. Like that it takes place. Random. It won't takes place regularly, but it takes place randomly. Okay. And one more point. Even though the collisions will takes place randomly, so there is a time gap, right? There is a time gap between one collision to another collision. Yes or no? So collisions will not take place at a time all together. It won't take place. But one after another it will take place. Definitely one after another collisions will take place. There is a time gap. Yes or no? There is a time gap. So the average time gap between the two successive collisions, the average time gap between the two successive collisions is called relaxation time. Understood or not? So I hope it is very clear. So between one collision to another collision, that was successive collision. So here one collision is there. After 100th collision, we have to take the time. No, we should not take like that. Okay, so one first collision after 55th collision, we have to take the time. No, we should not take. So first collision after 30, after 20, after 60. No, we should not take. So we should take. So successive collisions, one after another. Okay, one collision takes place here. So again, the electron is going to hit or meet the next collision. So between this time gap, the average time gap between two successive collisions is known as relaxation time. That is known as relaxation time. So I hope it is very clear. Understood or not? So next one, current and drift velocity. Current and drift velocity. We'll discuss about current and drift velocity. Current and drift velocity. Current and drift velocity. Drift velocity. Okay, so here you can see. So current and drift velocity, right? So this is the conductor. This is the conductor. Understood, Anna? The area of the cross section. This area of the cross section, and this one is the area of the cross section. Area of the cross section A. Area of the cross section A. And length of the conductor. So from here to here is length. This is the length of the conductor L. L I am taking. So current is moving in this direction. Electrical field will be there. So electrons are moving opposite to the current direction, opposite to the electrical field. Right? So like this it is moving. That is called drift velocity. Drift velocity. Understood or not? So I hope it is very clear. So we know velocity equal to displacement by time taken. So that this interval I'm taking, this time interval I'm considering. Okay, this time interval delta t. Understood or not? So here Vd equal to L into delta T. So L equal to Vd into delta T. So we have to take the volume, right? We have to take the volume of this conductor. So only this particular volume we have to consider. Number of electrons are moving in this particular volume. So that is volume equal to length into area of the cross section. Volume equal to length into area of the cross section. So what is the length? Vd into delta T into A. That is the volume. And the number of electrons present in the particular volume. Number of electrons present in the particular volume. So electron density we are taking. Number of electrons present in the particular volume. N is the electron density. So Vd into delta T into A. Okay, so N A V D delta T. So we know quantization of charge. Quantization of charges. So number of electrons into E N A V D delta T into E. Okay, then so delta Q equal to N E A V D into delta T. Understood or not? So what about current? Current I equal to what about current? I equal to delta Q by delta T. Delta Q by delta T. So N E A V D delta T by delta T. So delta T get cancelled. So what is the current relation? I equal to N E A V D. N E A V D. Understood or not? So VD, right? Now what about current density? Current density is nothing but current density J equal to I by A. Current density equal to current density J equal to I by A. What is I? So J equal to N E A V D by A. So A get cancelled. Current density formula is J equal to Ne. So current density J equal to Ne Vd. Understood or not? So very important. Very important. So once again I will explain. Listen carefully. So area of the cross section. So length of this conductor. So we are taking only this particular length and volume. So this particular volume and with this time interval between here to here. Time interval. So we know velocity equal to displacement by time taken. So V equal to L by T. So we know Vd drift velocity. So electrons are moving in the conductor. Electrons are moving in the conductor. Understood or not? So Vd equal to L by delta T. L equal to Vd into delta T. So L equal to, so volume. Volume equal to length into area of the cross section. So Vd into delta T into A. Understood or not? And length is Vd delta T into A. So area is the area of the cross section. So number of electrons present in the particular volume. Number of electrons present in the particular volume. So n small n is electron density, free electron density. So n into Vd into delta T into A. So Na Vd delta T. We know. So quantization of charge delta Q equal to Na Vd delta T into E, and so Q equal to Na Vd delta T. And coming to the current, I equal to delta Q by delta T. Current I equal to delta Q by delta T. Substitute this one Na Vd delta T get cancelled. I equal to Na Vd. So now current density. What is the current density? J equal to current density J equal to I by A. Current density J equal to I by A. Understood or not? So just check once. right? So I hope it is very clear. So this is the current density. J equal to I by A. So I equal to NEA BD by A. So A get cancelled, then so current density. This is the current density formula. Current density. Current density. Is it clear? Yes. So current and drift velocity. I hope it is very clear. Next one, Ohm's law I'll discuss. Surely we'll discuss Ohm's law. So next Ohm's law only. Yeah, next Ohm's law only I'll discuss. Ohm's law. Okay. So shall we discuss about activity? Activity I'll discuss Ohm's law. After that I'll get one by one. So very clearly you'll get. Then after that we'll go to the next one, resistance. Factors depends on resistance. So temperature dependence of resistance. After that resistors are connected in series combination. Resistors are connected in parallel combination. So after that, we will discuss about electromotive force. After that, Kirchhoff laws. After that, internal resistance. After that, we will discuss heating effect of electric current. After that, we'll discuss about cells are connected in series and cells are connected in parallel combination. So there are many more points are there. So we'll discuss one by one. So let's start. Here, Ohm's law is nothing but the potential difference. So here I'm taking the resistor. This is the resistor. So potential difference V I am taking. So current is passing I. The potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So V is directly proportional to I. V equal to IR. V is directly proportional to I. V equal to IR. Once again, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. And one more point, at constant temperature, and physical conditions also same. Physical conditions also same. Okay. So for doing activity, what are the materials required? For doing activity, what are the materials required? We will discuss materials required. Okay. So first one is four cells 1.5 volts of each. Four cells 1.5 volts of each. Coming to the next one, nichrome wire. Okay, so 0.5 meter length. Coming to the third one, ammeter. Coming to the fourth one, voltmeter. And coming to the fifth one, so switch. And coming to the sixth one, switch. Coming to connecting wires. Okay, so these are the points. Four cells, 1.5 volts of each, nichrome wire, ammeter, voltmeter, switch, connecting wire. So these are the metals required. And coming to the circuit diagram. So draw the circuit diagram. Circuit diagram. Circuit circuit diagram. So we can draw the circuit diagram like this. So here I'm taking the four cells, one, two, three, four. Okay. Ammeter, so resistor, switch, So across resistor, I'm connecting the voltmeter here like this. So current is passing. So here one by one we have to connect. One by one we have to connect. Understood or not? So one by one. Okay, so observe carefully. Here, how many cells we connected? 1, 2, 3, 4. So, 4 cells, 1.5 volts each. Nichrome wire of length, 0.5 meter. Okay, 0.5 meter length. Now, first we have to connect one cell and note down the reading of ammeter and voltmeter. First, we have to connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells. Connect to two cells and note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. Repeat the process for 3 and 4 cells. Repeat the process for 3 and 4 cells. Understood or not? Once again, observe carefully. Once again, observe carefully. Here you can see. So one cell you are connecting. First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. Repeat the process for 3 and 4 cells. So you have to connect 3 and 4 cells and note down the reading of ammeter and voltmeter. Ammeter and voltmeter. So then if you draw the graph, so you have to mention in the tabular form. You have to mention in the tabular form first. Then after that, we have to draw the graph. We have to draw the graph. So here I'm considering like this. This is the graph. So sorry, tabular column first. Serial number, the number of cells, ammeter reading, voltmeter reading. So serial number 1, 2, 3. So serial number of cells, ammeter reading, voltmeter reading, V by I form equal to R. So 1, 2, 3, 4, 1, 2, 3, 4. Okay. So we have to connect 4 cells. As I mentioned, you have to connect 4 cells. Serial number of cells, ammeter reading is the current reading. So and voltmeter reading is the potential difference, and V by R, V by I equal to R. So we know that from Ohm's law, V equal to IR, that is I equal to V by R. I equal to V by R equal to V by I. R equal to V by I. Understood or not? So like that we can take. If you draw the graph, so I'm drawing the graph. This is the graph. This is the graph. Okay. So V on y-axis, I on x-axis. The graph is straight line. Okay. The graph is straight line for ohmic conductors. The graph is straight line for ohmic conductors. Ohmic conductors. Ohmic conductors. So what do you mean by ohmic conductors? The conductors which follow Ohm's law. The conductors which obey Ohm's law. The conductors which accept the Ohm's law. So those are called ohmic conductors or circuits or resistors. So anything we can say. The conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. Understood or not? For ohmic conductors, the graph is straight line. For non-ohmic conductor, the graph is curved. So here V on y-axis, I on x-axis. The graph is curve for non-ohmic conductors. For non-ohmic conductors. Understood or not? So I hope it is very clear. Non-ohmic conductors. Here, non-ohmic conductors. Non-ohmic conductors. So what do you mean by non-ohmic conductors? The conductors which does not obey Ohm's law. The conductors which does not obey Ohm's law, those are called non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductors. I hope it is very clear. So coming to the next one, that is, so now you got to know the resistance. So the Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Understood or not? So now you can see resistance. Resistance. So what do you mean by resistance? Resistance is nothing but the phenomena of opposing the electric current. The phenomena of opposing electric current is known as resistance. So resistor. So here 3 points I'll tell. One is resistor, and second one is resistance, and third one is ohm, and the fourth one is symbol. So here you can observe resistor is a device which is used to oppose the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. SI unit of resistance is ohm. So this is the symbol. This is symbol. This is about a resistor. Understood or not? So now factors. So I will explain one activity. One activity. After that, we will discuss about difference between resistance and resistivity. Resistance and resistivity. Okay. So here you can see. So I'm taking between A and B. So here ammeter reading. So battery. So switch I'm taking here like this. Okay. So positive terminal, negative terminal, current is flowing. Understood. So it is closed. Now you can observe here. So between A and B, you have to take nichrome wire. You have to take nichrome wire of length A and area of the cross section A. So here I am taking length L and area of the cross section A. So connect between A and B and observe the reading of ammeter. So I have to connect. So nichrome wire. First you have to take nichrome wire of length L and area of the cross section A. So you have to you have to connect between A and B and observe the reading of ammeter. And connect to second one, connect twice of the length. Okay, so length is twice, area of the cross section A. Okay, nichrome wire only. Nichrome wire only. So you have to take in these two cases. Even in the third case also you have to take nichrome wire. So first case nichrome wire of length L and area of the cross section A. You have to connect between A and B and observe the reading of ammeter. And in the next second case you have to take the twice of the length nichrome wire, twice of the length and area of the cross section A. Connect between A and B and observe the reading of ammeter. And third case area of the cross section must be doubled. Okay, so you have to take twice of the area of the cross section and length is same. Twice of the area of the cross section and length is same. Okay, so that too nichrome wire only. Nichrome wire only you have to take. And coming to the fourth case, so instead of nichrome wire, you have to take copper wire. Instead of nichrome wire, you have to take copper wire and connect between A and B. So once again, so in the first three cases, you have to take nichrome wire. In the fourth case, you have to take, okay, copper wire. So here we are changing the material. Okay, we are changing the material. And one more point, compared to the first two cases, in the first case, length L and area of the cross section A, and in the second case, length is doubled and area of the cross section is same. So here we are changing the length. So first condition. Coming to the second condition, observe. So case 1 and 3. Case 1 and 3. Here in the third case, we are doubling the area of the cross section. We are increasing the area of the cross section. Okay. So length is same. Length is same. Area of the cross section is doubled. Length is L. So as it is, we are taking in the first case. Is it clear? And coming to the fourth case, so in these three cases, case 1, case 2, case 3, in these three cases, so we took we took nichrome wire. In the fourth case, we are taking the copper wire. Understood or not? So by observing all these, okay, so all these cases by connecting all these wires between A and B, we can conclude that resistance is directly proportional to L. Resistance is inversely proportional to area of the cross section. Resistance is directly proportional to L by A. Resistance equal to rho into L by A. Resistance is rho into L by A. Understood or not? So resistance depends on length of the conductor. Resistance depends on length of the conductor. If more length is there, more resistance will be there. Okay, if more length is there, more resistance will be there. Okay, so small break, water break. Okay, so I hope it is very clear. Yes. So now observe carefully here. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So resistance is directly proportional to L by A and R equal to rho into L by A. So here rho is the resistivity, R is the resistance. R is the resistance, rho is the resistivity. Rho is the resistivity. R is the resistance, rho is the resistivity. Understood or not? Yes. So now we'll discuss the differences between resistance and resistivity. So resistance and resistivity. Okay. So now you can see resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. R equal to L by A, rho into L by A. So here rho equal to RA by L. So resistivity is very important. Resistivity. So definition, if you want to know the definition, if you want to know the definition of resistivity, by observing the formula, we can get to know. Resistivity is equal to resistance of the conductor per unit length and unit cross-sectional area. Okay. Resistivity is equal to resistance of the conductor per unit length and unit cross-sectional area. I hope it is very clear. Understood or not? So here, SI unit of resistance is ohm. Symbol I am taking ohm. And here we can say, so resistance depends on temperature. Resistivity depends on nature of the material. Nature of the material. Understood or not? And here you can see resistivity. Resistivity does not depend on length and area of the cross section, but and here one more point, SI unit of resistivity is very important. SI unit of resistivity. So here rho equal to ohm meter square by meter. Meter get cancelled. Now ohm meter. So that is ohm meter. Understood or not? So this is very important. So resistivity does not depend on length and area of the cross section. Resistivity does not depend length and area of the cross section, but resistivity depends on temperature. Resistivity depends on temperature. Okay, so and one more thing, as I mentioned, resistivity depends on nature of the material. Nature of the material. I explain on activity, right? I explain on activity. That is, so in the three cases, I took nichrome wire. In the fourth case, I took copper wire, right? So I placed the copper wire. So by that we can observe the reading in the ammeter. Understood or not? So resistance and resistivity both depends on nature of the material and temperature of the conductor. Temperature of the conductor. So I hope it is very clear. Yes. Now so this is about difference between resistance and resistivity. So R is directly proportional to L. R is inversely proportional to area of the cross section. R equal to R is directly proportional to L by A. R equal to rho into L by A. So SI unit of resistance is ohm. So symbol it is there. SI resistance depends on temperature. Resistance depends on nature of the material. Resistance depends on nature of the material. Coming to resistivity, SI unit is very important and derivation is very important. You have to derive. So right from starting onwards, you can take R is directly proportional to R is inversely proportional to area. R equal to rho into L directly proportional to L by A. R equal to rho into L by A. Rho equal to RA by L. Rho equal to ohm meter square by meter. Meter get cancelled. Then you will get rho equal to ohm meter. Rho equal to ohm meter. SI unit is very important. So even in the MCQ's point of view also very important. Understood or not? So make sure that you are learning SI unit of resistivity. And here, so resistivity depends on temperature. Resistivity depends on nature of the material. Nature of the material. Understood or not? So these are the points. These are the points. Next one we will discuss about. We'll discuss about resistors are connected in series combination or before that temperature dependence of resistance. Temperature dependence of resistance. Okay, temperature dependence of resistance will discuss. So temperature dependence of resistance. Yes. So I will give one incident. So observe carefully. So when temperature of the conductor increases, the free electrons in the conductor also increases, or those free electrons will move with a greater amplitude. Understood or not? So when temperature increases, free electrons in the conductor increases. So those free electrons will move with a greater amplitude. Yes or no? So at that particular instant, what happens? Resistance and resistivity decreases. Conductivity increases. Understood or not? Resistance and resistivity decreases. Conductivity increases. Conductivity increases. Is it clear or not? As temperature increases, resistance and resistivity decreases. Conductivity increases. Conductivity increases. Point number one. So as I said, so free electrons moving to greater amplitude, right? Free electrons are moving with a greater amplitude. Then what happens? So those are moving in a closed enclosure. So in a closed conductor. So within a less area. Then what happens? They are moving the greater amplitude, moving in a closed enclosure. It is a closed path. So in one direction, then collisions will take place. Then keep on collisions are taking place. Then resistance and resistivity increases, conductivity decreases. So the final conclusion is when temperature increases, resistance and resistivity of the conductor also increases. Is it clear? When temperature increases, resistance and resistivity also increases. So I hope it is very clear. Now we can take so R equal to R naught. Okay. 1 plus alpha into T minus T naught. We can also take delta T. So R equal to R naught plus R naught into alpha. So alpha is the temperature coefficient of resistance. Alpha is the temperature coefficient of resistance. Alpha. So we are talking about alpha. Alpha is the temperature coefficient of resistance. So R naught into alpha T minus T naught. Then alpha equal to R minus R naught by R naught into T minus T naught. We can also write R minus R naught by R naught into delta T. R naught into delta T. Understood or not? Is it clear? Right. So coming to the next one. So alpha equal to, directly I am writing rho minus rho naught by rho naught into delta T. Rho naught into delta T. So here alpha is the temperature coefficient of resistivity. Temperature coefficient of resistivity. Is it clear? Yes. So next, so I'll discuss once again. R equal to R naught 1 plus alpha into T minus T naught. So we can take it, then alpha will get it. Alpha equal to R minus R naught by R naught into T minus T naught. So then we can take delta T. So alpha equal to rho minus rho naught by rho naught into delta T. Is it clear? Yes. So next one. Now resistors are connected in series combination. Resistors are connected in series combination. We'll discuss after that. Resistors are connected in parallel combination. Okay. So let's do it. Resistors are connected in series combination. 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 Okay. Now you can see R1, R2, R3 across R1, V1, across R2, V2, across R3, V3. So here you can see throughout the circuit current is same. Yes or no? Throughout the circuit current is same. So that is Is equal to I1 equal to I2 equal to I3 equal to I. So from Ohm's law, V equal to IR. From Ohm's law, V equal to IR. Understood or not? So here Vs equal to V1 plus V2 plus V3. Then IRs equal to IR1 plus IR2 plus IR3. Okay, shall I take I common? So I'm taking I common. So that is I common R1 plus R2 plus R3. So I get cancelled. Then RS equal to R1 plus R2 plus R3. Understood or not? So observe carefully. Observe carefully. So here R1, R2, R3. So three resistors are connected in series combination. R1, R2, R3. So if the three resistors are connected in series combination, then current is same throughout the path. Current is same throughout the path. I is same. I is same. But the potential difference across R1, R2, R3 is different. So that's why Vs equal to V1 plus V2 plus V3. So from Ohm's law, V equal to IR, right? From Ohm's law, V equal to IR. So IR is equal to IR1 plus IR2 plus IR3. So IR is equal to I am taking common R1 plus R2 plus R3. I get cancel, RS equal to R1 plus R2 plus R3. Understood or not? So I hope it is very clear. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, Rs equal to Nr. If n number of resistors are connected in series combination, Rs equal to Nr. Rs equal to Nr. Understood or not? So I hope it is very clear. Coming to the next one, resistors are connected in parallel combination. Resistors are connected in So resistors are connected in parallel combination. Okay, observe carefully here. R1, R2, R3. Okay, R1, R2, R3 are connected in R1, R2, R3 are connected in parallel combination. So potential difference is same across R1, R2, R3. But here you need to understand one thing, current is different. I1, I2, I3. Current is different. But potential difference is same across R1, R2, R3, but current is different. I1, I2, I3. Is it clear? So ammeter, so anyway, battery, switch, current is current is different. Now potential difference is same. Vp equal to from Ohm's law, V equal to IR, I equal to V by R. Then Vp equal to V1 equal to V2 equal to V3 equal to V. Understood or not? So Vp equal to V1 equal to V2 equal to V3 equal to V. Is it clear? Yes. So now we can see here from Ohm's law, IP current we have to take. Current we have to take. Okay. Current we have to consider IP equal to I1 plus I2 plus I3. Okay. So IP equal to I1 plus I2 plus I3. Understood or not? So then V by RP equal to V by R1 plus V by R2 plus V by R3. V by R1 plus V by R2 plus V by R3. Okay. So I hope it is very clear. Now V I am taking common. 1 by Rp equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. So VB get cancelled. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Understood or not? So if resistors are connected in parallel combination, if resistors are connected in parallel combination, R1, R2, R3. So potential difference is same, current is different. I1, I2, I3 from Ohm's law. V equal to IR, I equal to V by R. Okay, current is same throughout the path. Current is same throughout the path. Understood or not? One check here. One check. So then IP equal to I1 plus I2 plus I3. Then V by RP equal to V by R1. Anyway, V by VP equal to V1 plus VP equal to V1 equal to V2 equal to V3 equal to V. So that's why V by RP equal to V by R1, V by R2, V by R3. So V I am taking common, VB get cancelled. 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Understood or not? So I hope it is very clear. So coming to the next one. So now resistors are connected in series completed, resistors are connected in parallel completed. So each and every circuit cannot divide into simple series and parallel, right? Okay, some circuit we can't able to divide like that. In that case, we will use Kirchhoff's laws. Okay, so we'll use Kirchhoff laws. Those are, one is junction law, and second one is loop law. Loop law. So what is junction law? Kirchhoff given two laws. One is junction law, another one is loop law. So what is junction law? So the algebraic sum of all the currents reaching at a junction equal to zero. The algebraic sum of all the currents meeting at a junction equal to zero. Okay. So how we can write like this? We can take, so current is reaching, so I1, I1, I2, I3, I4. The algebraic sum of all the currents reaching at a junction equal to zero. So that's why. So I1 plus, this is about junction law, first one. So I1 plus I2 equal to I3 plus I4. Understood or not? Coming to the loop law. Loop law is very, very important. Loop law is very, very important. So we'll see the loop law. The algebraic sum of all the potential difference in a loop of circuit is zero, right? So now point number one. So I am taking the cell positive terminal, negative terminal. Sorry, here for negative, positive. So this the path. Okay. So through the cell we are moving. That is a path. So EMF of this cell is positive, right? Coming to the next one, when you are moving from negative terminal to positive terminal, so positive terminal to negative terminal. Here, negative to positive, final end is positive, so that's a positive. So we are moving from positive to negative. Then EMF of the cell is negative. EMF of the cell is negative. And coming to the third one, so this is a resistor R. Okay, so current is passing like this. Current is passing. So across the resistor, so you are passing in this path, you are moving in this path, then along the current direction. Along the current direction you are moving, the IR term is negative. Potential drop will be there. And coming to the fourth one, so this is the resistor. So you are moving opposite to the current direction. Opposite to the current direction. The path is very, very important. In which direction you are taking the path, that is very, very important. Be aware of it, in which direction you are taking. So along the direction of the current. Okay. So along the direction of the current, if you take, the IR term is negative. So opposite to current direction, if you take, the IR term is positive. So potential drop, potential increase. Here potential drop will be there. So here when you are moving in the cell from negative terminal to positive terminal, negative terminal to positive terminal, so the potential EMF is positive. So when you are moving from positive terminal to negative terminal, EMF of the cell is negative. So finally in which position you are, finally where you are reaching, so to which point you are reaching, that is very important. So you are reaching to the positive side. So positive EMF. You are reaching to the negative side. So negative EMF. And here along the direction of the current you are moving. So the potential drop will be there. V equal to minus IR. So opposite to the current direction you are moving, the potential increases will be there. So potential increase there. So V equal to plus IR. Understood or not? So I hope it is very clear. So these are the points. These are the points related to Kirchhoff laws. Kirchhoff laws. Actually, what is EMF? So, sir, you are saying EMF, 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 EMF. So, what is EMF? So, I will give a brief idea about EMF. So, normally this is the cell. Okay, so battery. Switch, resistor, resistor. Here current is passing positive terminal, negative terminal. So we know that when you on the switch, okay, when you on the switch, so current is start flowing. Positive charges will be moving from positive terminal to negative terminal of this cell. Okay, charges are moving from positive terminal to negative terminal. We know that. We know that immediately when you on the switch, so the key is closed. So from positive terminal to negative terminal, charges are moving, right? So then, what if the charge is there at the negative terminal of this cell? Okay, so from negative terminal to positive terminal, so the positive charge should move, right? Yes or no? The one which is making the positive charge to move from negative terminal to positive terminal, or the work done to bring unit positive charge from negative terminal to positive terminal, or lower potential to higher potential, or the influence that makes the positive charge to move from negative terminal to positive terminal of the cell are inside of the cell. Inside of the cell, so the work is done to bring unit positive charge from lower potential to higher potential. For negative, from negative terminal to positive terminal, that is called EMF, electromotive force, E equal to W by Q. E equal to W by Q. Understood or not? So I hope it is very clear. So that is EMF of the cell. So here simple point. Normally when you on the switch, positive charge will move from positive terminal to negative terminal. But when it is there, the positive charge is there at the negative terminal. The work is done to bring unit positive charge from lower potential to higher potential, from negative terminal to positive terminal, that is EMF of the cell. E equal to W by Q. E equal to W by Q. I hope it is very clear. So coming to the next one. Coming to the next one. So Kirchhoff laws completed, and so one more point is there, internal resistance. Internal resistance. Normally, when electron is moving in the cell, so through the electrolyte, it experience some resistance. Okay, when electron is moving in the cell, it experience some internal resistance, some resistance. That is called internal resistance, denoted with a small R. Okay, anyway, current. So potential drop will be there. If resistance is there, potential drop is there. So then EMF of this cell is, so I'm taking this positive terminal, positive terminal, negative terminal, negative, positive, EMF. So coming here, internal resistance R. So here A, B. So potential between A and B is E minus IR. Okay, is R is the internal resistance. R is the internal resistance. So very important. So make sure that you are understanding, learning this point. Internal resistance. When electron is moving in a cell, it experience some resistance. It experience some resistance. That is the internal resistance. Internal resistance. And coming to the next one. So heating effects of electric current. Effect of electric current. So the final one is heating effect of electric current. So heating heating effects of heating effects of electric current. Electric current. Understood or not? Heating effect of electric current. That is V equal to W by Q. V equal to V equal to Q. So W equal to VQ. So potential equal to work to bring unit positive charge. Normally potential difference is nothing but here 2 points I'll tell. So anyway point came, so that's why I'm telling 2 points. So potential difference. So potential difference is nothing but, so within the conductor, if you are taking point A to point B, so positive charge is there, we are doing some work. So work done to bring unit positive charge, work done to bring unit positive charge from point A to point B within the conductor, work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. So SI unit of potential is volt, SI unit of work is joule, SI unit of charge is coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Coming to the electrical potential, electrical, electrical potential. So electrical potential, electrical potential. Electrical potential. So here positive charge is there, infinity. Positive charge is there, infinity. We are doing some work. So this is the required field. So work done to bring unit positive charge from infinity to the required field. Work done to bring unit positive charge from infinity to the required field is called electrical potential. So V equal to W by Q. Understood or not? So here we are talking about potential difference. Work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor. Understood or not? So like that. Like that. So here we can see heating effect of electric current, heating effect of electric current. So V equal to W by Q, just now we discussed about it. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor, from one point to another point within the conductor. V equal to W by Q, W equal to VQ. So P equal to rate of doing work. So electrical power, P equal to rate of doing work. So W equal to VQ by T. VQ by T. So P equal to, so we know rate of flow of charge is called current. Rate of flow of charge is called electric current. I equal to Q by T. Rate of flow of charge is called electric current. So now we can see V into Q by T is I, VI. So then P equal to VI, P equal to P equal to VI. Understood or not? So whatever the energy is given to the conductor, so that will become, okay, so VI into T. So we know V equal to IR, V equal to IR. We know V equal to IR. Understood or not? Substitute V equal to IR in this case. So whatever the energy is given to the conductor will become in the form of heat. So that is H equal to I square RT. Heat produced in the conductor, heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Understood or not? So once again observe carefully here. So potential difference V equal to W by Q, W equal to VQ, V equal to W by Q, W equal to VQ, P equal to W by T, rate of doing work. So W equal to VQ, VQ. So the rate of flow of charge is called electric current. Rate of flow of charge is called electric current. Q by T equal to I. P equal to V and T, Q by T. So VI. So P equal to VI. So we know V equal to IR. So what is V equal to IR? Ohm's law. And whatever the energy is given to the conductor, that will become in the form of heat. H equal to I square RT. Heat produced in the conductor, heat produced in the conductor is directly proportional to heat produced. Heat produced in the conductor is directly proportional to Okay. So I hope it is very clear. Understood or not? Yes, just check once. Check once here. So I hope it is very clear. So heat produced in the conductor. So heating effects of electric current, heating effects of electric current. So B equal to W by Q, W equal to VQ, P equal to W by T, VQ by T, Q by T is I. Then P equal to V into Q by T, Q by T is I, P equal to VI. So whatever the energy is given to the conductor, that will be in the form of heat, that will become in the form of heat. H equal to I square RT. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Is it clear or not? I hope it is very clear. So coming to the next one. Cells are connected in series combination. Cells are connected in parallel combination. Okay, so we'll discuss now. Cells are connected in series. Cells are connected in series. Connected in series. Okay. Now cells are connected in series combination. All cells are connected in series combination, right? So now net EMF, net EMF equal to NE. Okay, so what about net internal resistance? Net internal resistance, net internal resistance, net internal resistance, internal resistance, net internal resistance equal to NR. So total resistance, external resistance is there, external resistance R is there. Understood or not? External resistance, external resistance capital R. Okay, I equal to net EMF by I equal to net EMF by total resistance, total resistance. Understood or not? What is net EMF? NE by, so NR plus R. So that is, if resistors series, cells are connected in series combination. Cells are connected in series combination. Is it clear or not? Next, cells are connected in parallel combination. Cells are connected in parallel combination. We'll see. Cells are connected in parallel combination. Okay. Now cells are connected in parallel combination. Okay. So now we can see net EMF. Net EMF equal to E net internal resistance. Net internal resistance equal to normally N by R. Now R by N. So R by N. So we need resistance, right? We need resistance. So now we can see external resistance. External resistance. External resistance is capital R. Is it clear? No. So I equal to net EMF by net resistance. Net a total resistance. Total resistance we can say net EMF, net EMF, total resistance. So what is that net EMF? E by R by N plus R. So I equal to E by R by N plus R. Is it clear? Just check once. Is it clear or not? So I hope it is very clear, right? Okay, so I hope it is very clear. So this is about resistors are connected in cells are connected in series combination, cells are connected in parallel combination. All right. So next we'll do a few problems. Few problems. So we'll do a few basic problems. After that, we'll go to some high level standard problems. Okay, so let's start. Do the problem. Okay. A copper wire of resistivity. Question number 1 is a copper wire. Question number a copper wire of resistivity 1.6 into 10 power minus 8 ohm meter. So as a cross-sectional area of 20 into 10 power minus 4 centimeter square. Calculate the length. Calculate the length of this wire required to make a 10 ohm coil. Okay, try to do this question. So once try to do this question. So try to do this question. What is the answer for this question? Let me know. So what is the answer for this question? Let me know. So resistivity is given, area of the cross section is given, resistance given. We have to find out length. How to do it? Okay. So here you can see a copper of resistivity. Resistivity is given. So here you can see resistivity rho equal to 1.6 into 10 power minus 8 ohm meter. And as area of the cross sectional area is given 20 into 10 power minus 4 centimeter square. Calculate the length of the wire. So we have to find out the length. We have to find out the length. So, but resistance is given R equal to 10 ohm. So, what formula we can take? What is the formula for this? What is the formula? What formula we can take? Okay, so observe carefully here. Now substitute the values. So that is R equal to rho into L by A, L equal to RA by rho, R equal to rho into L by A, L equal to RA by rho. Understood or not? So now you can see here. Substitute L equal to rho R value 10. And here you can observe they given centimeter square. They given centimeter square. Understood or not? So we have to do it. So 20 into 10 power minus 4. 1 meter equal to 100 centimeter. 1 centimeter equal to 10 power minus 2 meter. Then 1 centimeter square equal to 10 power minus 4 meter square. Right? So then substitute here. So 20 into 10 power minus 4. Then R equal to 10. A equal to 20 into 10 power minus 8. Rho equal to 1.6 into 10 power minus 8. So 10 power 8, 10 power 8 might get cancelled. Then, so 200 by 1.6 into 10 by 10, you'll get 2000 by 16. So L equal to 125 meters. Because all are converted into SI units. Right? So that's why you can check once. Once check the answer. Is it correct or wrong? So check once carefully. Is it clear or not? Understood or not? So you have to carefully observe the readings. Carefully observe the readings in which how they given. Okay. So coming to the next one. So one more question I'll give. Try to solve it. One more question. Okay. So next one. A current of question number. A current of current of 500 milliampere flows in a series circuit containing an electric lamp and a conductor of 10 ohm when connected to 6 volts battery. So find the resistance of the electric lamp. Okay, so try to answer this question. Try to answer to this question. A current of 500 milliampere flows in a series circuit containing an electric lamp and a conductor. So just check once. So answer is, so here you can see, so a current of 500 milliampere, I equal to 500 milliampere and a series connecting. So here conductor, so RC equal to 10 ohm. Then battery is given potential difference 6 volts. So now they have to find out resistance of the electrical lamp. Resistance of the electrical lamp we have to find out. Understood or not? So we have to find out the resistance of the electrical lamp. Is it clear or not? So what formula we can use? V equal to IR. So what is the formula? V equal to IR we can use, right? So V equal to IR. And here they given I equal to 500 milliampere. 500 milliampere. So 1 milliampere equal to 10 power minus 3 ampere. 10 power minus 3 ampere. So substitute here. So I equal to 500 into 10 power minus 3. Understood? So that is ampere. So anyway current. Now we can see V equal to 6. I equal to 500 into 10 power minus 3. And the resistance is how much? Here RC plus RL. RC plus RL we have to substitute, right? So that's why here 6 by 500 into 10 power minus 3. Then RC given, RC how much? 10. 10 plus RL we have to find out. So if it is go 6000 by 500 equal to 10 plus RL. So 0, 0 get cancelled, 5 12 ja. Then you can see RL equal to, so RL equal to 12 minus 10, then RL equal to 2 ohm. RL equal to 2 ohm. Is it clear or not? Just check once. Is it clear or not? First you have to identify. So current, after that, so given data. So current they given in milliampere, you have to convert into amperes. So here you can see I equal to 500. I equal to 500 milliampere flows in series circuit. Conductor resistance is given. So potential difference is given V. I, R, V. So RC we have to find out. RL we have to find out. RL. So here 1 milliampere equal 10 power minus 3 ampere. 1 milliampere equal 10 power minus 3. I equal to 500 into 10 power minus 3 ampere. So then you'll get V equal to IR. So V6 I and RC plus RL, that is R. So we can take this is R. This is R. Then you can substitute all the values. Then you are getting RL equal to 2 ohm. RL equal to 2 ohm. Is it clear or not? So I hope it is very clear. Next one. Next one, we'll go to the next one. Next question. Let's discuss about next question. Okay, so next question is, here you can say three question, three 2 ohm resistors, 2 ohm resistors, A, B and C are connected in such a combination, in such a way in such a way in such a way so that the total resistance, such a way that the total resistance, the total resistance of the combination, total resistance of the combination is 3 ohm. Okay, show the arrangement. Show the arrangement. So question is, show the arrangement. Show the arrangement. Show the arrangement of the, show the arrangement of 3 ohm resistors, 3 resistors, 3 resistors and understood. So let me know the answer. Those who know the answer, let me know. Okay, so how to connect? How to connect? Let me know. Let's check once. So what is the answer? So check once and let me know how to do it. How to do it. So anyone knows the answer? Just kindly let me know in the comment section. Okay, so here you can see. So three 2 ohm resistors. Three 2 ohm resistors, right? Three 2 ohm resistors connected in such a way that total resistance of the combination is total resistance of the combination we have to get 3 ohm. We have to get 3 ohm. So show the arrangement. So you have to see. First, I'm connecting two resistors in series combination. So I will tell one guess method. Okay. So I'll teach one logical method. Okay. So to understand, to analyze. Anyway, so this is very simple. So that's why you can able to do it. If it is any like a complicated or a little difficulty or moderate to difficult question comes, how to solve. So that time I will tell one logic. So for in that case, so how to identify, how to solve the question. Okay. So if you want to do it, I will tell one thing. So first of all, identify. So whether you are able to get in series combination or parallel combination. Okay. First, whatever they given resistors, connect in series combination. That's enough. First to connect in series, then parallel. Okay, still if you are not getting, then we have to go to the another methods. So now you can see here, first one I am taking 1, 2, 3. So 2 ohm, 2 ohm, 2 ohm. So I connected all three resistors in series combination. So will you able to get 3 ohm by adding all these three resistors? 2 plus 2 plus 2. So 2 plus 2, 4. 4 plus 2, 6. 6 is not equal to 3, right? So this method is not working. Okay, so we cancel this method. And one more method. So I'm connecting all three resistors in parallel. 1, 2, and the next one is 3. I'm connected. So 2, 2, 2. So three resistors are connected in parallel combination. So will you able to get three final answer, three as a final answer, three as a resultant, three as a equivalent resistance. So let's try. Okay, so 1 by 2. So 1 by 2 plus 1 by 2 plus 1 by 2. So I'm taking R 1 by R. So 2, 1 plus 1 plus 1. So that is 3 by 2. So 1 by R equal to 3 by 2. So 3 by 2 is not equal to 3, right? Or even 2 by 3 also not equal to 3. So in these two methods, we are not getting the final result. Understood or not? So in these two methods also, by doing in two methods also, by solving in these two methods also, we are not getting the result. Then what to do? So what is the next step? What is the final conclusion? So we can do on one more way. That is, so this time you have to change the combination. So you followed series combination, you followed parallel combination. Okay. So you followed in series combination, you followed in parallel combination, but we didn't get the result, right? So we didn't get the result. So what we have to do? So we will do different methods, like one in series, remaining in parallel, or two in parallel, one in series. Like that, if you do it, then we may get. Understood or not? So like that, we have to try to solve. Okay, so you have to follow in different methods. If you follow only one method, if you are not getting, you have to follow in different methods. Understood or not? So now I will do in different methods. So here you can see. Now add so two resistors in parallel and one resistors in series. Okay, so if you're not getting an idea, so how to do it, how to solve it, how to follow, how to take from where to start. Okay. how to consider, how to assume. If you're not getting any idea about solving the problem, you do only one thing: follow series combination. So add all the resistors. Whether you are getting the final result or not, check. If you're not getting, leave. Coming to the next step, parallel combination. Add all the resistors in parallel combination. Check once. If you're not getting, leave. So go to the another method. Okay, that is combined method, like two in series, one in parallel, one in two in parallel, one in series. Like that, if you do it, definitely you will get the answer. Okay, so definitely you'll get the answer. So that, like that, you have to follow. Like that, if you follow, so you will get answer in easy way. Otherwise, you do one thing. After doing like this many times, then you'll get an idea. Okay, series all connect, so we are not getting parallel, all divide. So 1 by r, 1 by r2, 1 by r1 plus 1 by r2, 1 by r3, like that. If you do it, so if you're not getting, then immediately you'll go to in different methods. So like that, if you're going to different method, definitely you'll get the answer. Definitely you'll get the answer. So try to do in that way. Understood or not? You have to follow in that way only. You have to check. Okay, so whether we are getting in this method answer or not, whether we are getting in this method answer or not, you have to check each and every time. If you are not getting, so go to another method. So after solving, after doing few methods and few ways, so finally you'll get to know how to do it in a easy way, how to solve in a simple way, how to solve in less time. Okay, so like that, if you do it easily, you can do problems. Understood or not now? So 2 ohm and 2 ohm and 2 ohm. Now you can see, so 2 ohm plus 2 ohm. So these two are in parallel, right? So parallel means how to do it? 1 by Rp equal to 1 by Rp equal to 1 by R1 plus 1 by R2. That is nothing but 1 by 2 plus 1 by 2. That is 1 by Rp. Then 2 equal to 1 plus 1, 2 by 2. So 1. Then Rp equal to 1. Okay. So final result you are getting 1. And here also you can see here. So 1 ohm and here 2 ohm. So 2 plus 1 is 3 ohm. So the final answer you are getting, right? That's enough. So that is a simple method to solve the problem. That is simple method, easy way to solve the problem. Understood or not? So you have to check. You have to check each and every time. Each and every time. So whether you are getting in this particular method or not. So you have to check. Understood or not? So coming to the next one. So we'll do one more. So one question. So try to solve this one. How much work is done? How much work is done? Work is done in moving a charge of 2 coulomb from a point of 118 volts to a point at 128 volts. So try to solve this question. Try to solve this question. Okay, so just check once. So how much work is done in moving a charge of 2C from a point of 118 volts to a point at 2? So try to solve the question. Anyone knows the answer? Let me know. So identify the given data. Identify the given data each and every time when you are reading the problem. Identify the given data, then you can try to solve the problem. Okay. So V1, V2 given, charge is given. So we have to find out work. Understood or not? We have to find out work. So now you can see here V1 is given, V1 is given, V2 is given. V1 equal to 118 volts, V2 equal to 128 volts. V1 equal to 118, V2 equal to 128. So now we have to find out. So anyway, charge is given Q equal to 2C. Q equal to 2C. So what formula we can use? Yes, very good. 20 joule is correct. Nice. Okay. So V equal to W by Q. We can solve V equal to W by. So here V2 minus V1. V2 minus V1, that is 128 minus 118 equal to 10 volts. Then so potential is 10 volts. Potential is 10 volts. So charge is given. So then V equal to W by Q. So we have to do work, right? We have to do work. So W equal to VQ. V means 10. So charge means 2. Then W equal to 20 joules. Is it clear or not? Check once. Is it clear? So answer is correct or not? Let me know. So coming to the one more question. So try to solve this question. Let me know the answer. So just check once. What is the answer? Okay then. Now see the question. So a piece of wire of resistance is 20 ohm, and so length is increases. So L2 I'm taking 2L. Okay, twice of its original length. So calculate the resistance of the wire in U. If length is doubled, area of the cross section is become half. Length is doubled, area of the cross section becomes half. So then R1 is 20 ohm, R2 we have to find out. See L1 equal to L, A1 equal to A. Now formula is anyway same material, resistivity does not change, resistivity same. So R1 rho 1 equal to rho 2. Then so R equal to rho into L by A. In this case, so we can take R1 by R2 equal to L1 by L2 into A2 by A1. R1 equal to how much? 20 by R2 equal to, and L1 is 2, sorry, L1 is L, L2 is 2L. Area of the cross section is how much? Area of the cross section is A2 is A by 2, so A1 is A. Then 20 by R2 equal to LL get cancelled. So A get cancelled 1 by 4. Then R2 equal to 20 into 4. Then R2 equal to 80 ohm. R2 equal to 80 ohm. Then R2 equal to 80 ohm. Is it clear? Yes. So I hope it is very clear. Just check once. Right? So okay, coming to the next question. Coming to the next one more question. Okay, so so I will tell. So this question is very important. So in the previous question also I mentioned this type of questions they will ask. So try to find out this question. How can how can three resistors three resistors three resistors of resistance 2 ohm, 3 ohm and 6 ohm 6 ohm be connected 6 ohm be connected to give a total resistance of A equal to 4 ohm, B equal to 1 ohm. Okay, how can we connect? How can you connect? Let me know. So very simple one. Very simple one, as I mentioned many times. If you like the content, do like, share, and subscribe to Student the Brand. If you like the content, if you like the channel, do like, share, and subscribe to Student the Brand. So click on like button. Click on like button. So give your support to the channel. Let me know you understood the concept. Okay, shall we do it? So how you will get 4 ohm and 1 ohm by taking 3 resistors. Okay, let's see here. So what are those 2 ohm, 3 ohm, 4, 6 ohm? So here 1, 2 ohm, next 3 ohm, and the next 6 ohm. So do like, share, and subscribe to Student the Brand. If you like the content, if you like the channel, so let me know understood the concept. Okay, click on like button, share to everyone as much as possible, as soon as possible. So this live class almost more than 2 hours. Okay, so more than 2 hours. So right now it's nearly 135 minutes. Okay. So let me know. Just click on like button. Click on like button if you like the content, if you like the channel, if you like my explanation. So do like, share, and subscribe. Student the brand. So three resistors. So I have to get 4 ohm. How to get? As I said in the previous case, connect all the three resistors in series. So are you getting answer? So if you connect series 2 plus 3, so 5, 5 plus 6, 11. No. So among these two, no 11 answer. And you connect a parallel combination 6, 1 by 6 plus 1 by 3 plus 1 by 2. Let's try. Okay, so I'm connecting 1 by 6, 1 by r equal to 1 by 6, 1 by 3 plus 1 by 2, 6, 1 plus 2 plus 3, 6 by 6. So we got the answer, that is 1. So we got B, that is by connecting in parallel combination. As I mentioned, you have to check. You have to check in which combination you are getting the answer. You have to identify. How you can identify? So connect all resistors in series, connect all resistors in parallel, then you check. That's enough. That is only the method. Okay. So now you can see. Now I'm taking parallel combination. So these two are in parallel, one in series. Because if you do this one, you'll get two, right? In parallel combination. So that's why I'm connecting like this. And you have to identify 3, 6, 2. Okay, so here you can see 1 by 3 plus 1 by 6. How much you will get? 6. So 2 plus 1, that is 1 by R. R equal to 6 by 3, that is 2 ohm. R equal to 2 ohm. And so 2 plus 2. So 2 plus 2, how much? 2 plus 2 is 4. Understood or not? So you got the 4 also. So you got the answer. Is it clear? So just simply understand. So first you have to connect all resistors are in series. Next all resistors are in parallel. Then you can connect in this way. Then you'll get the answer. So do like, share and subscribe to Student the Brand. Share to your friends. Ask your friends to join to the class. Okay. So that's enough. So thank you so much for joining and attending, listening. Thank you so much for joining and attending and listening the class. So do like, share, and subscribe to Student the Brand. So this is Vasavasa signing off. If you like the content, share to all your friends. Ask your friends to join to the class. Thank you.